All right, so we are working on lesson 3-2. So we're going to use the two diagrams below. All right, so we have two separate diagrams below here. And we're going to sit there and pull out information for every one of these. Now, listen carefully. I'll tell you for each one which one to write something down. Now, I want you to write your answer down right away. Then we'll compare answers between all of us on lesson 3-1's review. All right, first thing I need you to do, from the word transversal, draw the arrow to the transversal on the diagram on the left. Just draw an arrow to the transversal to the diagram on the left. And everyone should draw in one where? The middle one, right? So when you're doing, remember, a transversal is a line that it's going to have to be coplanar with the other two lines that intersects two lines at two distinct points. And because of that, we'd have the words interior, we'd have the words exterior, and it would help us locate different angles. All right. In the diagram to the right, the bottom right over here, I need a pair of parallel lines. You guys go ahead and write down a pair of parallel lines for the diagram to the right. Just write it up here. That's all you need to do is write them right next to it. All right, who's got a pair of parallel lines for me? All right, Brooke, what do you got? AC and AG. All right, you said AC, so line AC is parallel to line. You said EG? Yeah. Did anyone pick different than Brooke? Josh, what did you pick? Yeah, he chose DH is parallel to CG. Perfect. Good pair. Love it. Good choice. All right. Now, using the diagram on the right again, give me a pair of perpendicular lines. A pair of perpendicular lines. And if I ask for lines, you give it as lines. Thank you. Keep distractions away from that young man. Thank you. All right. Thank you for keeping him in check. All right. Perpendicular lines. All right, middle row. Someone give it to me. Jacob.
It's line AC is perpendicular to line CD.
Very good. So we had line AC is perpendicular to line CD. Make sure you go with the obvious answers. Now, do we have other ones that we can use, guys? Yeah. How about, for instance, can we do HG with any lines? So line HG, could that go with line EG or line FH? Yeah, so we have those as well. All right, the diagram on the bottom left, give me a pair of corresponding angles. Give it to me third row over here. A pair of corresponding angles. What's about?
Angle 1 and angle 3.
Yeah, angle 1 and angle 3. Guys, if I have a transversal intersecting two lines, how many pairs of corresponding angles should I have? How many pairs total? 4. There should be 4. Remember, this is one that gives you 4. So we said 1 and 3, but what would 2 correspond with? So angle 2 would go angle 4. Guys, what would angle 5 correspond with?
7.
And angle 6 goes with? Angle 8. Exactly. We have 4 different pairs we should be able to get. All right, to the diagram on the right, give me a pair of skew lines. I need a pair of skew lines for the diagram on the right. What was the hint I would tell you to look for with skew lines? How should you make it? They do what? Look like they're passing over each other, right? Very good. All right, if you think you got it. Bethany.
Line EF and line C.
Yep, great one to do. Line EF and line CG. Perfect ones to use. Great example. Anyone pick a different pair? Corin.
Line AB and line DH.
Yeah, line AB, I love it, and line DH, those would be also skew. Any other pairs than this? Anyone have different than that? Josh.
Line AC and line DH.
Said line AC, DH, yeah, that one going up in front and the one going horizontal in the back. Perfect. My hat's falling off. Gotta be good. All right, I need a pair of alternate interior angles using the diagram to the left. A pair of alternate interior angles. Is that right? Yes, question. Go for it.
Is it a segment or a line?
If I ask for a line, you're going to give me what? A line. This is a finite drawing to represent a bigger picture. So if I ask for lines, name it as line. If I ask for a line segment, give it to me as a what? Line segment. Perfect. Nope, good question to ask. Just notation. Do what it asks in the words. All right, so a pair of alternate interior angles. Who's got this for me? Leah. All right, angle 3 and angle 6. Now, Mikey, you had your hand up earlier too. What's my other pair?
Angle 2 and angle 7.
Very good. Angle 2 and angle 7. Awesomeness. I need a pair of same side interior angles on the diagram to the left. So same side. Evan.
Angle 6 and angle 7.
All right, angle 6 and angle 7. What's our other ones, guys? Yep, angle 2 and angle 3. I'm going to take you serious. All right, alternate exterior angles. Right? That's our alternate exterior ones. Bethany.
Angle 1 and angle 8.
Yep, angle 1 and angle 8. Or we could say angle 5 and what? 4. I was doing my dance of my arms going far apart from each other. It's an easy way of remembering those, isn't it? Now, if you can identify these when the diagram doesn't look too good. All right, sorry. All right, anyone who's watching this video, understand we are at Young and Old Day at Wheaton Academy, and I have people acting as grandparents in my room. All right, anyway, trying to be serious right now. Okay, trying to be serious. All right, now, today you are going to learn 1 postulate and 3 theorems. Now, so they're very much scenarios that you have to know. I know you guys love learning these. They're so important. But you need to make sure that you have these. Let me put it this way. You know, I told you vertical angles are something you need to know till the end of time, linear pair till the end of time, midpoint, angle bisector. These you're going to use and they're going to show up on standardized tests as well. So make sure you know how to work with these. The first one is a postulate. You guys remember what a postulate is? Yeah, it's a statement that is accepted as true. It can be proven, but we know it's true, right? So the first one's called the corresponding angles postulate. So let's write it down on here. It's the following. If 2 parallel lines are cut by a transversal, other way of saying that is intersected by a transversal, then the pairs of corresponding angles are congruent. I'm going to abbreviate there a little bit. So if 2 parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. Now, there's a scenario that's very huge that we know on this. It's the idea of what type of lines? Parallel lines. So notice they're marked right away in the diagram. The moment you have lines parallel, this should be one of the very first things that come to your head. You know your corresponding angle pairs are going to be congruent to each other. But guys, this is one of the few times that if you look at things, it really makes a visual sense. Remember when we looked at vertical angles, it was like, oh yeah, they're the same shape. They look the same size, right? And then we proved it. The same type of idea. I can't prove it here, but you're going to get the exact same thing every time. Because if you have 2 parallel lines, look at angle 1 and angle 3. Do they look like they're both obtuse angles?
Yeah.
Don't they even look like they're the exact one?
Yeah.
Because they are. Now, because they are. And look at that. Because of vertical angles, we could even show 6 and 8 have the exact same scenario, right? 6 and 8 are corresponding. Look at here. Don't these go together? 5 and 7. They're corresponding. They look the same shape because they are. That's the big deal I want you to know, because they are. And then we also know that 2 and 4 would go together. So think about this. If I have parallel lines in a transversal, how many angle measures do I really have? 2. Between vertical angles and linear pairs and just what we know about corresponding angles, there's only 2. Now this says corresponding angles postulate. It's a nice name. However, I actually prefer if you would learn it more as a conditional statement that we would use on a regular basis. I actually prefer this because it makes your mind think a little bit differently. But oh look, what symbol do I have here? Yeah, my if then, my conditional form. So this is really what I want you to memorize. If I have parallel lines, then I know corresponding angles are congruent. really, that in the parentheses is what I care about more than even the name. You can use the name if you want, but you also need to be able to write it out if I ask you to. But it makes sense. Now, because of this, I can prove the next 3 theorems no matter what. I'm not going to prove all of them, but we'll talk about it a little bit. So the next 3 theorems, which I'm pretty sure is not going to be a surprise to you guys, are all proven because of it. All right. So here I have line J and line K. They are parallel to each other. But this one's called the alternate interior angles theorem. So what pairs am I looking at? All right, look at your pairs. Look at 1 and 4. What do they look like? They're alternate interior angles. Do they look the same size, same shape? Because guess what? They are. Okay, that's exactly what it is. And we can prove that using corresponding angles in linear pairs. So let's write this one down. If 2 parallel lines, and you could use the parallel symbol instead of writing out the word parallel if you want, are cut by a transversal, then alternate interior angles are congruent. If 2 parallel lines are cut by a transversal, then alternate interior angles are congruent. So obviously when I'm working with these, you can see we talked about angle 1 and angle 4 look, but don't 2 and 3 also look the same way? Yeah, they're congruent too. Now, do you think I really want the alternate interior angles theorem written down most of the time? No, I prefer to have this phrase. If parallel lines, alternate interior angles are congruent. Because I want you to think, the moment I say, oh look, there's 2 parallel lines, you go, oh yeah, corresponding angles are congruent, or alternate interior angles are congruent. Do you have tools in your tool belt, basically, in order to solve problems then? Because if I have this hypothesis, I have some conclusions I can run with. Yes?
Why do we have to know the theorems if we can just use the postulate to resolve?
Because then you'd have to do more steps to prove it. Because remember, a lot of times a theorem takes away all the little steps you'd have to show in a proof. So, and I want to do that as much as I possibly can.
Oh, so we can't use a postulate?
You could. You can, but you'd have to do more work. And you don't want to do more work. All right. Let's do the next one. Alternate exterior angles theorem. Alternate exterior angles theorem. Guys, that would be 1 and 4 and 2 and 3, correct? Our hand motion, like going farthest apart from each other. But again, if you look at these, look, when you have parallel lines, are they the same shape, same size? Yeah, totally when you work with it. So let's write it down. If 2, and notice how you can abbreviate this to make your life easier. If 2, use your parallel symbol. Lines are cut by a transversal, and some people will just put trans down instead of transversal, that's fine. Then alternate exterior angles are congruent. And you should have 2 pairs then. We have like 1 and 4, 2 and 3. Because we even know that those 2 would go together. But it makes sense. Again, how in the world would you even prove that? Well, let's talk about it for a moment. How would I prove alternate exterior angles are congruent? Guys, we'd put an extra angle in here. All right, we'd put an angle, let's say 5. What would you know about angle 1 and angle 5? They're congruent, right? So you'd say, all right, angle 1 is congruent to angle 5, because if I have parallel lines, corresponding angles are congruent, right? Then look what my next proof would be. Could I then say angle 5 is congruent to angle 4? Why are angle 5 and 4 congruent? Yep, the vertical angle theorem. Now look, what do I know about 1 and 4 now? They're congruent, right? Yep, transitive property. We didn't recognize it, guys. That's good. We just did a mini proof. You know what the only thing I didn't write down was the given. You know what your given is? Parallel lines. That's all it was. That's the only thing I didn't write down was the given. We just did a mini proof. You just proved it. the reason why I want to know the alternate exterior angles theorem is I don't want to have to go to these steps. I want to go straight to the bottom step, right? It just saves me time. All right, now, again, I prefer if you write it out as a conditional statement. If we have parallel lines, then alternate exterior angles are congruent. Not bad. So, if I give you parallel lines, you know corresponding angles are congruent, you know alternate interior angles are congruent, and we know alternate exterior angles are congruent. What do you think about same-side interior angles? Yeah, they're not going to end up being congruent, because do they look at 1 and 3, do they look congruent? No. Yeah, and these are going to be supplementary instead. So let's write it down. If two parallel lines are cut by a transversal, then same side interior angles are supplementary. Now, funny little story. I was teaching, this always lands somewhere near homecoming. And one year, I don't know what it was, but Mr. McDonald decided that I was going to wear a banana outfit for homecoming. So I'm literally wearing one of those huge, giant banana outfits. I had a cup on my head, so it looked great. And I'm trying to teach same-side interior angles. Now, one way I do is, like, I do anything for you guys to help you memorize, so within reason, right? And so one of the things that I do is to think, like, if you're on the same side, you're going to go the same direction. So I just do this little dance for you. I'll just go same side, supplementary, right? And it's weird enough with the red hat on that I'm wearing, but, like, same side, supplementary. And I'm doing this, and my students were just like, you know, that look of like, what is this woman doing? And then it hit me. I'm in a banana outfit. I look absolutely ridiculous. And all you see is this banana going, you know. But, you know, it's one of those great homecoming stories. I got $5 gift card out of it for winning like a dress up for the teachers. But like, it literally, I was trying to teach an important concept. You know, I thought it was kind of fun, rhythm, you know, same side, supplementary. My students named it the same side shuffle. I felt like I had this new dance move, and the whole time I'm just being a banana.
Wait, did you do the exterior ones in a banana too?
You know, I probably was going like, oh, that would look, oh, I'm scary now thinking about homecoming. Look at this. Yeah, that was a great day in math class, I'm sure. Those kids now are in college and scarred for life. But it's the fun stuff. But so understand, anytime I say same side, I'm going to do the same thing to you, but it's not going to be in a banana outfit, okay? Just a weird red hat. All right? Same side, what, guys?
Supplementary.
Supplementary. And so anytime you're stuck, you're going to see me just do the same side shuffle, but just not in a banana outfit or hopefully this red hat after today. But make sure you know the phrase, guys. Parallel lines, same side. It shuffled, nice. Interior angles are supplementary. We're actually going to prove that one in a little bit. We're going to prove why they're supplementary. Now, this is one thing you're going to be having to do on your homework. Hint, hint. Quiz next week on Friday, October the 13th. Quiz next week. You need to know how to do these. You need to know how to solve, but you also need to know why you do it. Are you guys with me on this? So on this first one, it says, find each angle measure and tell which theorem or postulate you applied in order to solve the problem. If you don't tell me the name, you have to write it out. So that's kind of your options on here. So the very first one, I want to know the measure of angle 1. How do I find the measure of angle 1, guys? Abby.
You subtract 180 by 133.
And what do we get? 40 what? 47 degrees? Now, okay, Abby, let's keep it up. What is your theorem or postulate that you used?
Same side interior angles.
Yeah, same side interior angles theorem. Now, I would write it out, but if you wrote the name down, you're totally correct. So if parallel lines, then same side interior angles are supplementary. You do, because you're giving their scenario out there. And if you said the name of it, again, I'm okay, as long as you said it called same side interior angles theorem, then I'm okay with it. Does that make sense? All right, let's go to the next one. I'm looking for the measure of angle 2. Who's got the measure of angle 2 for me down? We got the measure of angle 2. Drew. Yeah, it's 119 degrees. All right, how did you know it was 119 degrees, Drew? Yeah, it's the corresponding angles postulate. So you can either write corresponding angles postulate or write down if parallel lines, then corresponding angles are congruent. Can you which one do you think I would like more? The bottom one, because it lets me know very much your way of thought and if then. Because think about it, if I give you parallel lines, think law of detachment here. Can you then assume the rest? Then your hypothesis, your conclusion is assumed true. Excellent, let's keep going on this. All right, next one. Ooh, let's have a little bit of fun. I want to find the measure of angle ABC. I'm looking for this angle from here to here. Isabel.
So, because A3 is because A3 is linear pair with A.
Okay.
Angle A, then you can find what angle A is.
All right, so you use the linear pair here. It's not really angle A because it's more than one angle, but I know where you're talking. She's using the idea of the linear pair. Are you guys following her so far? So she ended up getting that to be, what is that, 97?
Yeah, and then because angle A or whatever is corresponding to angle X.
Or ABC. Yeah, so what's going to be your reasons? You used what first? Yeah, and then corresponding angles postulate, right? You used two.
Couldn't you switch those up?
Could I switch them up?
Yeah.
No.
No, yeah, you can. You just have to do it differently.
Could you do, could I do corresponding right here? Or how about this? Let's just really switch things up. Who said I couldn't use my alternate exterior angles theorem? Right, did any of you use that? You can use the alternate exterior angles theorem. Notice you still end up using the linear pair to help you out. All right, let's have a little bit of fun. Want to switch it up again? How about the fact that you have vertical angles theorem? Then I have same side what? Is anterior angles, and they're going to be supplementary. As long as you're valid, are you right? So that was good stuff. Guys, I love the fact you saw it differently on here. There's more than one way be able to just justify yourself. Basically, what does justifying mean? Telling why, right? Being able to tell why. All right, let's have a little bit more fun with this one. Well, we're finding the measure of angle DEF, this one right here. All right, guys, how are we going to approach this one? Peter?
Question.
Yes?
When do you know when to use like linear pair theorem or definition?
Definitional linear pair just says they're adjacent angles with non-common sides make a line. The linear pair theorem lets me get the fact they're supplementary. So if I want to work numbers, linear pair theorem. Does that help, Peter?
Yes.
Awesome. All right, guys, what do I use here? Corbin?
You do the alternating interior angles theorem.
Yep. So I'm going to use my alternate interior angles theorem because if it's parallel lines, now remember, you don't have to write both of these down. If parallel lines, alternate interior angles are congruent. Now, so you set it up, guys. I get 8x minus 34 is equal to 5x plus 2. We're going to solve it. We get here 3x is equal to 36. X is equal to 12. Are we done yet? No, we got plug it in, right? We got to do it. The good old commercials. All right. So the measure of angle DEF is going to be 5 times 12 plus 2. How many degrees did we get, guys? 62. Multiple steps, but we're able to justify every part of it, right? Every part. Good stuff, guys. Remember, if in doubt, name an angle with 3 points. You know you're going to be exact with it. Just play connect the points. You got all down? All right, let's do a proof. All right, we're going to complete the proof for the same side interior angles. And honestly, there should be an extra step. The proof really should be the fact that angle 1 and angle 3 are supplementary. So we're going to change it, and we're going to make our own therefore, okay? Because that's literally what the theorem says. It doesn't say they add up to 180, but it says they're what? So let's go and let's make it so exact that it can't, which means we're going to have to add a step onto our theorem. Who cares? We can add a step onto our theorem. Doesn't bother me. Now, you should have had your, my diagram's not on my notes, but I think for you guys I drew it in, right?
Yeah.
All right, so, well, that's no, not parallel. And then we have our lines. We have 1, 3, 2, is that right? And then this is P, and then this is Q. All right, so first thing they do is they tell you, P is parallel to Q. What should I mark on my diagram?
It's already marked.
On yours, but what should I mark on my diagram? Arrows. A lot of times, guess what? They're not marked. So if not, you do it. And the moment you know that they are parallel, what starts running through your head? Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. I can't say same side or supplementary because that's what I'm trying to prove. But we know that's the case. So we're going to start with our given. P is parallel to Q. Line P is parallel to, killing me on the notation they used, but we're going to go with it. Given. Now, what's the next thing? They say linear pair theorem. What am I doing for linear pair theorem? Where in the world did I get a linear pair? 3 and 2. Very good. 3 and 2. So the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. Now, I think we should have put a step before that, but I'm using the book, so I'm not going to try to argue the book too much today. Shouldn't we have actually said that was a linear pair first? Don't you think? We should have said it was a linear pair first. All right, next one. What do I have now? We have angle 1 is congruent to angle 2. Where did that come from? Yep, that's your alternate interior angles theorem. You can write that down. I'm going to write it this way. If parallel lines, then alternate interior angles are congruent. But if you said alternate interior angles theorem, I give you full credit. All right, so far so good. Now what? Why in the world do I have definition of congruent angles on there? Jacob.
Since the measure of angle 2, you could say the measure of angle 1 equal to the measure of angle 2.
Yeah, because the two angles are congruent, I want to say that they're equal measures. We can use that definition of congruent angles in order for me to get there. The moment I do that, can I actually get what they had as their original proof statement now? Yeah, we can actually get the fact that the measure of angle 1 plus the measure of angle 3 is equal to 180, and that's using the substitution property. And the cool thing is, let's add a 6 onto here, guys. So therefore, if I know, right, that they add up to 180, they must be what to each other? Supplementary. So we know angle 1 and angle 3 are supplementary. And that's just definition of supplementary angles. Now, guys, if you didn't have that theorem, that's what you'd have to show every single time you want to show that supplementary angles were, same side interior angles were supplementary. Don't we like the theorem better? It saves us 5 steps, basically. So, not hard to do, not impossible, but I want to make sure that you guys have it down. All right, last question. It says, find the measure of the requested angles or variables. Also state which theorem you applied to solve the problem. So basically, you have to be able to tell me why it's okay to do what you did. So first things first, I want to solve for x. Solve for x. Josh, what would I do? Nope, you don't have to. I just want to, you can just tell me the base. It's kind of like what we did on the very first ones. Just give me the main theorem that you used. Thank you, Josh, for asking if you want to do a 2-column proof or not. Don't have to this time. What would I do first, guys? Bethany.
So corresponding angles postulate for x is equal to.
Exactly, great idea. Because I have the corresponding angles postulate, I know 4x plus 22 is equal to 5x. Notice, what did I do to my diagram? Did I mark it in my diagram too? So then I just solve for it, and I get x is equal to 22. I just subtracted 4x from both sides. All right, those of you who can't stand this, what property I'm going to use to switch it around? It should be your symmetry one, right? Oops. Symmetry. This is for those of you who want to do that. Symmetry property. I can't stand that. It just takes too much time. All right, moving on. But it's there for you.
That's right.
Yes.
I think you technically just do linear pair theorem with 70 times.
Oh, thank you. We weren't done with the problem, and that's exactly what I wanted someone to say. Way to do it. All right, Mikey said, hey, what if I don't want to use corresponding angles postulate? I also have a what? Don't we have a linear pair this way? So could I go 4x plus 22? What do we got here? Equals 270 plus 70 is equal to 180, and that's just using the linear pair theorem. And the answer is yes, you can do it that way. You get 4x plus 92 is equal to 180. Simplify before we move. What do we get here? 88. Oh, did we still get the same answer? Again, would Mikey be right long as he justified what he did right? Totally. Remember, more than one way is okay. As long as you're mathematically what? Correct. As long as you're mathematically correct. All right, the measure of angle ECF. I'm looking for the measure of angle ECF. Try to keep it easy on yourself. ECF. Gorman, please just tell me it's 70 degrees. How do I know it's 70 degrees without having to do any calculations? Yeah, the corresponding angles postulate. Again, I write both of these down. You guys only have to write one or the other. I haven't taken off on it. I might circle it just to remind you it's a postulate, but it's not one of those hills to die on as other things are more important to me than that. But just remember, it's because it's the postulate that we can do all the rest. All right, next one. The measure of angle DCE. DCE. There's a couple different ways you could do this one. Isabel. Could you say you use the substitution property? Would that work? If you showed me this, couldn't you just say that's the substitution property because I already knew what x was up above? Well, what could I use? Could I use another idea? Could I have done this? Could I use the fact 180 minus 70 equals 110? Wasn't that really the linear pair theorem I used? Or the idea of sum of the parts equal the whole? Vertical angle theorem would also work if you found the other angle first, right? I mean, you have a lot of different things. Like this one would be my linear pair theorem is what I'd use for that one. Or sum of the parts equal the whole, one or the other. I mean, you've got different options. Be able to justify it. Again, more than one way, it's okay. All right, guys, what do you think about homework? Not gonna be too bad? Notice the change in number 26. I think it might be for 25 too, but I'm not sure. I know number 26, make sure that you do a 2-column proof. Let me double check. I think it says do a proof otherwise, and I'm like, 2 columns only. Let's see what we're doing on here. 25, you just fill in on a 2-column proof. 26, write as a 2-column proof. It says a paragraph proof. Change it to 2-column. Your life will be easier on this one. All right, so